You know that frustrating feeling, right? When an analytical problem just hits a wall and absolutely won't budge. Our gut instinct is usually just to push harder. Throw more data at it, spin up more compute, train a heavier model, or just brute force a longer search. But in this explainer, we're actually going to look at why you shouldn't do that. Instead, the real breakthrough often comes from deliberately changing the problem's fundamental form.
Okay, picture this tangled, chaotic mass of a problem. We've all been there, working on an issue that is completely hopelessly stuck. But here's the thing. The problem usually isn't that your tools are too weak. It's actually a form mismatch. Think of it like trying to turn a hex bolt with a claw hammer. It's just not going to work. The operation you need simply can't act because the problem is locked in a state that completely misaligns with your solution. Maybe your data set is too raw, an equation is too tangled, or maybe the concept itself is just trapped inside the wrong analogy.
And what's really fascinating is how cross-disciplinary this reality is. Whether you're looking at representation learning in AI, or mathematical factorization, or coordinate changes in physics, people across all these fields solve stalled issues by shifting the object's form. They untangle the shape of the problem into something workable, and boom, entirely new operations suddenly open up. So these aren't the same specific methods, but they absolutely share the exact same underlying logic. Change the form, and new operations become possible.
Now, this shared logic brings us to something called the Universal Methodology Framework, or UM8 for short. UM8 is this massive, overarching ecosystem that identifies recurrent solution logics behind complex problem solving across basically all scientific fields. It shows us that these structural pivots aren't just lucky, isolated tricks. They actually belong to a much larger, cohesive methodology that spans completely different disciplines.
And zooming in within that broader UM8 framework, we have the transformation compass. This is our specific design space module for transformation-based problem solving. It basically takes this abstract, vague idea of changing a problem's form and turns it into an explicit, deliberate design space. It gives us a map, right? Showing us exactly how to maneuver when we hit that analytical wall.
To actually use this compass, we have to ask 4 sequential design questions. And, naturally, we start with purpose. Why are we changing the form in the first place? Like, what is the current form failing to give us? We really need to orient our design before we make a single change.
Because let's be honest, transformation isn't valuable just for the sake of changing things. It's only valuable if it yields a specific, needed gain. First up, we might transform for simplicity, just to reduce descriptive clutter so a human brain can actually reason about it. Or we might need efficiency, dropping the computational or memory costs so a machine can actually process it. Third, maybe we're looking for feasibility, taking a completely impossible task and making it workable. Or finally, alignment, making totally different data sets or conceptual frames play nicely with each other.
Once we know why we need a change, we hit our second crucial question. What exactly is being transformed? We need to pinpoint the precise object that's blocking our progress.
We have to explicitly target what we're changing. Are we acting on the formal structure, like tweaking the underlying mathematical equations? Are we changing the task formulation itself, altering the objectives or constraints? Maybe it's the data representation, like those latent embeddings we use in AI. Or perhaps it's the domain or reference frame, like shifting the coordinate scale in a physics problem. Or, and this is a big one, we might even need to change the conceptual frame, which is the underlying explanatory analogy we're using to even make sense of the situation.
It's really interesting to contrast these targets. Look at how different these approaches can be. On one hand, we might be changing a strict domain, like moving a problem across rigid analytical grids or reference frames. But on the other hand, we might be doing something much deeper, shifting the entire conceptual lens or abstraction we use to view the situation entirely. Both are totally valid targets, but man, they require completely different methodological approaches.
Which tees up our third question perfectly. How is it transformed? We know the why, we know the what. So what operational approach do we actually use to carry it out?
A learned AI embedding, a mathematical factorization, and a scientific surrogate model. These are not interchangeable things. They are very deliberate choices from a specific menu. We might choose a representation rewrite to just swap the variables entirely. We could use a structural reorganization to clump parts together into modules. We might apply a dimension change to project the problem down into a simpler, flatter space. Or we could use domain conversion, operational recasting, or conceptual reframing to fundamentally alter the procedural structure. You're essentially picking the right gear for the terrain you're on.
And the mechanism you choose radically alters your path forward. Just think about it.
Internally reorganizing a problem by splitting it into modular puzzle pieces behaves completely differently than structurally suppressing its degrees of freedom or changing its dimensions entirely. One method unpacks the problem while the other flattens it. Your approach absolutely has to match your specific roadblock.
Now this brings us to the fourth question. And honestly, this is the most critical turning point of the whole design. What must be preserved? Transformation is incredibly powerful, yes, but it's also really dangerous. It's so easy to make a problem simpler to solve while accidentally destroying the exact behavior, meaning, or structure that your task actually depends on.
Notice that stable outline anchoring the shape here? Even as the problem mass changes form, that structural ring remains totally intact. That's your preservation boundary. It's a constant reminder that the deepest, most vital design question isn't just about what we change, but what absolutely must survive that change intact.
We have to deliberately commit to our required fidelity here. Do we need strict, exact mathematical equivalence? Or is simply having recoverability enough, meaning, hey, we can just get back to where we started if we need to? Sometimes, semantic preservation of the core meaning is plenty. And in a lot of real-world cases, a controlled approximation, a bounded, acceptable loss of detail is perfectly fine as long as the conditions are explicit. You're basically moving from the strictest rules down to more flexible guidelines, completely depending on what your specific solution demands. For instance, requiring exact, rigid equivalence imposes an incredibly strict validity boundary, like mathematical interchangeability. That is far more restrictive than, say, simply preserving the structural integrity of a network's topology. If you choose the wrong preservation commitment here, your entire solution could be rendered totally invalid because you literally lost the very thing that made the data useful in the first place.
So when you force these four distinct questions to work together, purpose, object, approach, and preservation, the underlying logic of your workflow becomes totally explicit. This framework takes what used to be isolated, highly field-specific tricks and elevates them into cross-domain, reusable thinking tools. You aren't just throwing a random algorithm at a wall anymore. You are deliberately designing a transformation. The next time your analytical problem stalls out, just remember, you might not need a stronger tool, a bigger data set, or a faster computer. You might just need a better form. The transformation compass turns "I'm stuck" into a design question. What should change and what must remain true? So what rigid assumptions are you holding on to in your current work that might just need a change of form?